All right, so the second part of this binomial expansion assignment is to find the difference quotient. And we did this earlier in the year, so this is a good thing to review here at the end. So we're going to find f of x plus h by putting x plus h in for x. And then we're going to subtract the original function from it and divide by h. All right, so I am going to start with f of x plus h. That's going to be x plus h raised to the fifth. Then I'm going to subtract the original function, which is x to the fifth, from that and divide by h. All right. Now, when we learned this at the beginning of the year, we didn't know how to do binomial expansion, so we didn't do powers over 2, but we can do that now. So we're going to use Pascal's triangle. We're going to use the row that has 5 as the second number to raise this to the fifth power. All right, so it's going to be 1x to the fifth. And then because there's a plus sign, I don't have to worry about alternating signs. So it's going to be plus 5x to the fourth, h to the first. So the h power goes up and the x power goes down. And then plus 10 from Pascal's triangle, x to the third, h to the second, plus another 10 from Pascal's triangle, x power goes down, h power goes up. And then 5, x power goes down, h power goes up, and then it would be 1h to the fifth. Right? And then we're going to subtract the original function from it, and eventually we're going to divide by h. Now, when we did this before, it kind of worked out the same way. This step right here, everything that doesn't have an h ends up subtracting away. So x to the fifth minus x to the fifth becomes 0. And now that everything has an h, I can reduce all of these h's. So what we're going to have, 5x to the fourth, and then since this was h to the first, is going to completely cancel out. And then 10x to the third, and then 1h will cancel. 10x squared, 1h cancels, and just continue that pattern to the end of the problem. And that is the value of the difference quotient for the function f of x equals x to the fifth. Okay, so we're going to do the same thing for x to the seventh. We're going to use a different line on Pascal's triangle. So we would make sure we use the line that has 7 as the second number. So we'll have x plus h raised to the seventh minus x to the seventh divided by h. Right, this one's going to be a little bit longer. We'll have a couple more terms, so I'm going to have to write smaller. So I'm just looking back up at Pascal's triangle to get the next binomial coefficient. And I'm having the power on my x go down, the power on my h go up. And each time I know that the power, if I add these together, it needs to give me 7 each time. Then I will subtract the original function, which was x to the seventh, and I am going to divide by h. All right, so just like the last one, everything on that numerator that doesn't have an h cancels out. Then I can divide everything on that numerator by h, or reduce an h from each term. All right, and that's my difference quotient.